This is the last statistic that we're going to learn about in Unit 13. So the I can statement for 13.4a is I can compute the standard deviation. So the warm-up talks about these two words, standard and deviation. So let's take a look at A and B where it uses the word standard. So it says in A, the work was well above standard, and in B, this is pretty standard stuff here. Well, when we talk about standard, when it's used here, what we're using is we're talking about a measurement. We're going to say that a standard is the usual measurement. Get that right there, okay? So if his work was well above standard, it was way above the usual measurement. And if this is pretty standard stuff, it's just kind of the way things usually are, whatever that measurement happens to be. And then in C and D, we talk about the word deviation. So C says any deviation from his routine caused problems. And in D, it says they could not afford even a small deviation from the courses or from the satellite's course. So when we're talking about a deviation, what we're talking about is a departure from what usually happens. So let's write that down. Departure from the usual. I'll just write down usual right here. So if he, in C, if he departed from his usual routine, it caused problems. And if the satellite departed from its usual course, then they'd be in trouble there also. So let's talk about down here. So when we're using statistics to make decisions, because remember that's what one of the huge values of statistics is. So when we're using statistics to make decisions, there are two really important measures that we should be interested in. So we're interested in measures of center, and we're also interested in measures of spread. And we've talked a lot about those. Mean and median, those are very common forms of measures of center, mean and median there. And measures of spread are things like the range, the quartiles, the interquartile range, which we always abbreviate this way, the IQR. Let me make that Q look like a Q. There we go. Now, we've analyzed the mean and the median a whole bunch, and we know when they're appropriate to use, whether it's symmetric data or skewed data, whether there's a lot of outliers or different things like that. Now, measures of spread mentioned above, so the range, the quartiles, and the interquartile range, they're not really sophisticated enough to deal with some of the things that we normally run into. Okay, and some decisions that we've got to make. The most common and most useful way to measure the spread of data is something called the standard deviation. So the standard deviation. So as we mentioned in the warm-up, the standard is a normal way or a usual way of measuring something. The standard deviation gives us a very dependable way to measure how much the data deviates from the mean, because the mean is what usually happens. So it's a way of measuring the departure from the usual, the departure from the mean. So in other words, the standard deviation measures the variation. In other words, it measures the spread. Okay? It measures how spread out the data is. Now, the standard deviation is a little bit more complicated, a little more sophisticated than some other measures of spread, because these were actually pretty easy to compute. And maybe in 7th grade you learned about something called the mean absolute deviation. That's also pretty easy. Being more sophisticated and a little bit more difficult to obtain is what makes it very useful. But let's go ahead and take a look at the steps here. So there are actually 5 steps that we'll use in order to compute the standard deviation. So here are the 5 steps. The first thing we're going to do is we're going to find the mean of the data. We're going to find the deviation from the mean for each piece of data. And in order to do that, we're going to do the data minus the mean, and some of the answers will turn out to be negative. We're going to square each one of those deviations, and then we're going to sum those squares. We're going to add them up, and then we're going to find the average for all of those squared deviations. So it says divide the sum, so we get this sum up here, by n, and remember n is how many pieces of data we have in the data set, and then we take the square root of this average. So whatever the answer is in number 4, we take the square root of that. Now, I know that seems like a lot. It's actually not too bad, so let's go ahead and take a look. So here's example 1, and it says Joe has test scores of 60, 68, 69, 70, 90, 95, and 100. So Joe's kind of all over the board there. Annie's got scores of 78, 78, 79, 79, 82, 82, and 82. Okay? Now, what we're going to do is we're going to compute the mean for Joe and for Annie. So I'm going to bring up the calculator here. So I'll shrink this down. And this does get a little bit tedious, and we need to be using a regular old calculator for this. So if you've got one, go ahead and grab a TI-30 or something like that. It generally is a little bit easier. So here's what we're going to do. I'm just going to go ahead and add 60, and I'm going to make sure that I type every single one of these in correctly. So I've got 60, 68, 69, 78, 90, 95, and 100. Now, I always like to make sure that I've put the data in the right way. So I've got a 100, a 95, a 90, a 78. And then let's check the beginning of this list here. I realize this is a little tedious. So we've got 69, 68, and 60. So we're going to go ahead and add those together. So I'll hit enter and I get 560. Now we've got this many pieces of data. 1, 2, 3, 4, 5, 6, 7. Yep, that's a 7. So we're going to go ahead and we're going to divide by 7. So we'll divide that by 7 and we end up with 80. So Joe's mean is 80. So I'm going to put 80 right here. And then let's check for Annie. So for Annie, we're going to put in a 78 plus a 78 plus a 79 plus a 79. Now I'm going to go ahead and double check these first 4 while I've got them. So I've got them on the screen. That's excellent. Then I'm going to add 82, another 82, and then another 82. Whoops. Hit that 82. Okay, so yeah, I've got those last couple. Very interesting scores there. When we add those up, add those 7 scores, we get 560. So again, we're going to divide by 7. And when we divide by 7, we end up with 80 also. So the mean for both of these is 80. So we've got 80 on both. So you notice that they are exactly the same. So I'm just going to write that they're the same. So that's what we notice about the means for Joe and Annie. And then it says the mean tells us something about the center, but look at the data. What do you notice about the spread of the data? In other words, what do you notice about the variability, how spread out they are? Well, if we take a look at Joe's scores, he goes all the way from 60 on the low side all the way up to 100. He is all over the place. And the nice thing is things are organized in ascending order here. And then Annie, she's pretty darn consistent, okay? So she's right in there. So we're going to write that Joe is all over the place. So Joe all over the place, okay? Swinging all the way from 60 all the way to 100. And we're going to write down here that Annie is consistent, okay? So what we mean here is there's a lot of variability in Joe's scores, but there's not much variability in Annie's scores. Now it says compute the standard deviation and round to the nearest tenth. Now, we do want to mention that we've got to be careful when rounding, so we want to make sure that we don't round until the very end. So write the word end right here. We want to keep as much decimal accuracy as we can as we're doing these computations, so just keep that in mind. Now, what I'd like to do here is let's fill out this table, and we've got similar things on the homework. Some of them you might have to make your own table, and I'll show you how to do that. But let's take a look here. So the first thing we want to know is we need to keep track of how many scores there were. Remember, there were 7 scores for Joe, and there were 7 scores for Annie. And this one's mostly filled out for us, so the mean is 80 all the way through. So I'm just going to do 80 for every single one of those. And you'll notice that some of the deviations are filled out. And there's a little reminder here. It's the data minus the mean. That's why this ends up to be negative 20. So it's 60 minus 80, that's negative 20. 68 minus 80 is negative 12. 69 minus 80 is negative 11. 78 minus 80 is negative 2. 90 minus 80. Now notice the data, the score is above the mean, so this turns out to be positive 10. 95 minus 80 is 15, and 100 minus 80 is 20. Then we're going to take each one of these deviations and we're going to square them. So we're going to take negative 20 and we're going to square it. Now, just a quick reminder, if you do negative 20 and you square it, so let's just double check on the calculator. We want to make sure that we type this in the right way. So if I were to do negative 20 and then I squared that, it's going to say negative 400. But remember, we want to type it in the right way, which is negative 20. We want to square the entire deviation. So we're going to do negative 20 squared, we end up with 400. So this is 400. So you'll notice what happens here is every time we square this, if we're squaring a negative, we end up with a positive. So we've got negative 11 squared is 121. Negative 2 squared, that would be a 4. 10 squared is 100. Hopefully you remember this one. 15 squared. If not, go ahead and type it into your calculator. That's 225. And then we're going to add all of these up. So I'm going to clear this off, and we're going to do, I'm going to do 544, because I can just add the two of those together. And then I'm going to add these together. That's plus 125. Just a word of caution, if you're going to do this, better make sure you get it right. And then we're going to plus 325. Because if I add those together, and then I'm going to add the 400. And again, like always, let's just double check. There's a 400. These two make 325. These two make 125. And then that first one, of course, we'll just double check here, was let's see, 544, because that's what you get when you add the two of those together. So I'm going to hit enter and we get 1394. So that's the sum here. So 1394. And then here's how we find the variance. So variance is just a fancy word for the average of the squared deviation. So what we're going to do is we're going to take the sum here. We added up all those squared deviations, and then we're going to divide by whatever n is. That's why we need this n. That's why that's so important. So we're going to take that 1394. So I'm just going to go ahead and write that 1394, and we're going to divide by 7. So I'll just hit divide by 7, hit enter, and we end up with 199.142. So there's our 199. Yep, and I went ahead and I rounded it to 4 decimal places right here, because that 5 right here would round that up to a 9. Now, we've talked about the importance of rounding a whole bunch, and remember we said we don't want to round to the very end, so you wouldn't want to round this to 199.14. You want to leave all that decimal accuracy. I'm going to go out to 4 places just because that's about what we can fit in here. And then the very last thing we do is we take the square root of whatever that average is. So let's take the square root of that number. So I'm just going to hit second and square root. Now I could type this in from scratch, or you remember above the negative key is the ANS button. So that'll grab that last answer and it'll just find the square root. So we're going to find the square root. Now we want to go ahead and round. So this is round to the nearest tenth. So we're going to go 14. This would be 11, so it's either going to be 14.1 or 12. That's just going to be 14.1. So we're going to go 14.1 right here, and that right there is the answer. Whole bunch of little calculations just to get that right there, and that is a measure of how spread out this is. So let's take a look at Annie's data. Now remember, we need to figure out what the mean is, and we've got that already. It was 80, so I'm going to write 80 right here, and I'm going to do a little trick here. I'm going to draw a line down to here, and I'm going to write 80. So then we're going to figure out what the deviation is for each one of these. So again, it's going to be the data minus the mean. So it's going to be 78 minus 80, so that's going to be -2. 78 minus 80, that's going to be -2. 79 minus 80, that's going to be -1. That's going to be -1. 82 minus 80, that's going to be +2. 82 minus 80, that's going to be 2, and 82. So gosh, look how easy that is to do each one of those. And these numbers are small enough, we can probably just square those. Now remember, the advantage here is when we square this, it turns every single one of those into a positive number. So when we square -2, we get 4. We square -2, we get 4 again. Square -1, we get a 1. This would be a 1. And these, of course, would all be +4. So we're going to put a 4 on each one of those. So let's go ahead and add these up. Well, let's see. If I put those together, let's see, that's 8. And another 2, that's going to be 10. And then 4 times 3, that would be 12. So I think we're going to get 22 here. So I'm going to put 22 down here. And then I'm just going to go ahead and double check on my calculator. So that's 8 plus another 2. So that's going to be 10. Plus, let's see, that 12. Yep, we're in good shape there. So we've got our sum. Now we want to do the variance. The variance is the sum divided by n. So we're going to take that, and remember n is 7, so we're going to divide by 7. We're going to hit enter, and we get 3.14285. So 3.14, and then we're going to write down 29. And then the standard deviation is going to be the square root of that. So again, I'm going to hit second square root. I'm going to grab that answer so I don't have to type the entire thing in again. And I get 1.772. So if we round to the nearest tenth, this is going to be either 1.7 or 1.8. That 7's enough to bump that 7 up to an 8. So we're going to call this 1.8. Now the last two questions on this page, it says, whose standard deviation was larger? So if we look at the standard deviations, well, Joe had a larger standard deviation. So we're going to put Joe right here. And what does standard deviation measure? Well, remember, it measures the spread, it measures the variability. And remember, we were looking up here and in question C, it said, look at the data and figure out what's going on here. Well, Joe is all over the place. He's got scores down to 60 up to 100, but the average, the mean, is 80. So they're really spread far apart, but look how consistent Annie is. Her scores are all really close to 80. Look at how small those deviations are. 2 below to 2 above, whereas over here on Joe, he's 20 below the mean with his 60 or 20 above the mean with his 100. Now, I do want to quickly mention that if we did have to write these to the nearest hundredth, so let's say I came back here and we said hundredth. Now remember, hundredth is to 2 decimal places. then we do everything exactly the same. We just round differently at the very end. So on this one right here, we would say that this would be 1.77. So I'm going to put 1.77 off to the side here, and I'm going to put a dotted circle around that. I am going to go ahead and circle this 1.8 right here. And then if I were to go back, let's just double check and see what this was. So I have recalled that 199.1429 or 1428 as we had here. And then I'm going to take the square root of that. So we'll do the square root of that answer right there. So the other thing that we could write here, if we were to go to the nearest hundredth, we would just say, well, that's either going to be 14.11 or 14.12, but that one's not enough to bump it up. So we're going to say 14.11 if we did go to the nearest hundredth. So just kind of keep that in mind. All right, we're on the back side, and we've only got one more problem that we want to do with standard deviation before we turn you loose on the assignment. And you'll notice that there's no table here. That's okay, we can handle that. And it says find the variance and standard deviation for starting pay at local businesses. And you'll notice that we've only got 5 pieces of data here, so that's kind of good. So I'm going to write down that n equals 5. And it says be careful with the decimals and with rounding. And we want to keep 3 or 4 decimal places of accuracy as we're going through and showing our work. We try not to round till the very, very end, because every time you round, that introduces a little bit of inaccuracy. So let's be careful with this. So I'm going to go ahead and write here. I'm just going to write down that we're going to write the data. So I'm going to do 9 and 13 and $12.50, and 7 and 8.25 here. So there's the data. Now, you could try adding these together in your head and maybe add these together and get, what would we get, 21 or 22 or whatever. I found that when you're doing this, it's always a good idea to use a calculator, because if you make one tiny mistake, it's very frustrating to kind of recover from that. So I'll go ahead and bring up the calculator. And we're going to type this stuff in. So as silly as it might seem, we want to make sure that we get this right. So we're going to do 9 plus 13 plus 1250 plus 7 plus 8.25. We'll go ahead and hit enter, and we end up with 49.75. And then there are 5 pieces of data, so we're going to divide that by 5. So we end up with 9.95. So over here, I'm going to write down that we've got a mean of 9.95. Now, if you want to, you can write this down on every single one of them like I'm doing. If you wanted to save a little bit of time, and it actually is pretty quick on this one because there's so few of them, you could just draw a line down to the last one and then write 9.95 there. Okay, now we're going to figure out the deviation. So I'm going to just write DEV. And remember, that's going to be the data minus the mean. So we're going to take whatever this number is and subtract that one. Notice that the mean is bigger here, and watch what happens there. So we're going to do 9 minus 9.95. We get negative 0.95. So negative 0.95. This one's bigger than the mean, so when we do 13 minus 9.95, and again, you might be tempted to do a little bit of arithmetic in your head, kind of resist that, because again, if you make one tiny mistake, and I've done it before, you end up having to go all the way back and finding where your mistake was. So we're going to do 1250 minus 9.95. We get 2.25. And again, make sure that you're double checking as you're going through here that you've typed the right thing in and you've got the right thing out. So we'll do 7 minus 9.95. We end up with negative 2.95. Okay, and then the last one, 8.25. And let's see, we're going to subtract the mean, 9.95. Hit enter, and we get negative 1.7, which makes sense because this one's below the mean. So this is negative 1.7. And now what we want to do is we want to square each one of these deviations. So I'm just going to write SQDEV. Now we're going to take this and we're going to square it. So I'm going to type that into the calculator. I'm going to do negative 0.95, and we're going to square that, and we end up with 0.9025. So I'll write 0.9025, and we'll keep all 4 of those decimal places so that we've got a lot of accuracy here. And then I'll show you something down below that we can use to speed this up just a little bit. So this is 3.05, and because that's positive, you know, I don't need the parentheses on it. So we'll do 9.3025, and the next one is 2.55. So 2.55, we'll square that, and we end up with 6.5025. So 6.5025. And then we've got, okay, so here's what I want to show you. When we square this, it always turns out to be negative, because when we square two negative, or when we square a negative, we get a positive. Negative times negative is a positive. So one trick you can use is you can just say, look, this is going to be 2.95, and I'm just going to square that. And I get 8.7025. So 8.7025. And then just to show you, so if I did negative 2.95, close the parentheses, square that, I get exactly the same answer. So let's just do 1.7, we'll square that. We end up with 2.89, so 2.89. Now, I need to carefully add all these together, so I'm going to get a sum here. So let's check and see what we get. Again, very carefully, 0.9025. I'm going to double check because this is going to be off the screen before we're done with this. So, and then the next one, 9.3025, got that one, plus 6.5025, so a little bit of a pattern here, and then we're going to add 8.7025, and then this last one kind of messes it up, so we're just going to add 2.89. Okay, so I think I've got every one of those in there correctly, and we'll hit enter, and this is what we've got, 28.3. So we'll write down 28.3 on this, and then we need to find the variance. So remember, the variance is just a fancy word for the average of each of those squared deviations. So the variance is going to be this divided by 5 here, divided by n. So let's take that and divide by 5. So we end up with 5.66. 5.66, and I'm going to leave that. I'm going to go ahead and do this to the 100th. In fact, I'll write this up here. Let's say we're going to do this to the 100th place. So we've got that answer there. And then the standard deviation, so I'm just going to write STD period and then DEV, and we'll write down what that is. So let's see, we just take the square root of that last answer, the 5.66, hit enter, and we get 2.379. And we're going to go to the hundredths place, so that's either going to be a 0.37 or 0.38. That 9's enough to bump it up, so we're going to say this is 2.38. All right, so we've got that one done. That's how you do it, even if there's no table involved. So I'm going to come over here, and let's take a look at these questions at the bottom. So it says, why do we square the deviations? Well, if you stop and think about it, if we were to just add these up, we've got some that are below and some that are above. These are always going to cancel each other out, because the mean, that's kind of like the typical, the middle score, the usual one. So we've got some that are below, these ones that are negative are below, and these ones are above. So those are going to balance out. This is always going to add up to be 0. So what we do is we square those, so we're adding up how far they are away from the mean when we square that. So we don't care which direction it deviated. These ones are all below, and these two are above. We just want some measurement that keeps track of how far they deviated. So this one doesn't care. This doesn't have the direction because they're all positive, and then we take the average of that. So why do we square the deviations? So we end up with positive answers. And then here's the real question. Why do we take the square root of the variance to find the standard deviation? Now I'm going to let you think about that for just a second. So what we did is we took these deviations, we squared them. That made them so that they were positive. So we had positive answers, positive deviations. Then we took the average of that. We found the variance, and then we took the square root to find the standard deviation. So if you think about it for just a second, this all comes back to these ideas that we've been talking about from the beginning of 7th grade, and that is inverse operations. When we squared these deviations, we want some way to undo that, and the way we undo squaring is we take the square root. Okay, so why do we take the square root? Because it undoes squaring. Okay, so it kind of gets us back into a unit or a way of doing things or measuring things that makes a little bit more sense. Okay, so I'm going to come down here to the bottom here, and it says, please note that deviations use the mean of the data in the calculation. So just like the mean, it is very sensitive to outliers. So we'll write outliers here, and skewed data. So because of this, we ought to be really aware of this. When the data is symmetric, the mean and the standard deviation are the best measures of center and spread. But if it's skewed or there are outliers and things like that, then the median along with the range and the IQR, those are the best measures of center and spread when it's skewed. So when it's skewed, we're going to use the median and the range and the IQR. Median for center, range and IQR for the spread. But if it's symmetric, then we're going to use the mean and the standard deviation as measures of center and spread. So if you're ever in doubt, and unless the data is really skewed or it's very clear that they're outliers, then we're going to use these two symbols right here. That's going to be the mean. Okay, so X bar is the mean, and sigma, that is the standard deviation. Okay, all right, so now we know what those are. Go ahead and fill out the self-assessment, and good luck on the assignment.